Let's move on to the next question. Here we have state any two ways in which molecular structure of a gas differs from the molecular structure of a liquid. In a gas, the molecules are farther apart. The molecules are farther apart when compared to that of a liquid, and also the motion of the molecules is more random compared to or comparatively to that of a liquid. Compressibility is the ease with which a substance can be compressed. State and explain in terms of forces between the molecules how the compressibility of a gas differs from that of a liquid. It is obvious from the definition that gases are more easily compressible when compared to a liquid. This is specifically due to the fact that in a gas, the molecules are farther apart, as discussed before, and it is due to this reason that the intermolecular forces between the molecules in a gas are very weak, and that is why they are much more easier to compress. Moving on, figure 6.1 shows a weather balloon being inflated by helium from a cylinder. The helium that inflates the balloon had a volume of 0.035 meter cube. We can consider this as volume V1 at a pressure P1, which is equal to 2.1 into 10 power 6 Pascal. The pressure of the helium in the balloon is 1 into 10 power 5 Pascal, and its temperature is the same as it was when it in the cylinder. So pressure P2 is now given, while volume V2 is now being asked. We know that when temperature is maintained a constant, as stated, pressure times volume is a constant, or pressure V1 times volume, pressure P1 times volume V1 is equal to pressure P2 times volume V2. So written in terms of V2, we have V2 is equal to P1, which is 2.6 into 10 to the power of 6 Pascal, times V1, which is 0.035 meter cube, divided by P2, which is 1 into 10 to the power of 5 Pascal. Now we notice that pressure has decreased. So in consequence, volume should increase, and it increases to a value of 0.91 meter cube. Moving on, as the balloon rises up through the atmosphere, the temperature of the helium decreases. State the effect of this temperature on the change in the helium molecules. As temperature decreases, the average kinetic energy of the molecules decreases. And since kinetic energy decreases, the molecules become slower.